We are on page 9 of our chapter 8 notes, continuation of 8.4. Remember, we just introduced the topic of area, ratio of areas, and how it relates to scale factor of these objects. Okay, so let's look at an example. We've touched on the idea we're going to use the formulas before, but we'll alter them a little bit, as you will see. So the first example says here, Jim's laptop has a monitor with the dimensions 9 inches by 12 inches. The image of his laptop is projected onto the screen of a whiteboard. According to the documentation, the whiteboard has a screen area of 2,836.6875 inches square. So if you think about our classroom, what is in green, the 9 inches by 12 inches, that could be like the screen that I write on with my pen. And the 2,836 inches square, that is the projector screen that we have in the front of our classroom. So the question here is, the image on the whiteboard is similar to the image on the laptop. It says determine the scale factor used to project the image from the laptop to the whiteboard. So what is that scale factor? Okay, so first of all, what do we know? The actual object area, so we're talking about the laptop screen. 9 times 12, we get 108 inches squared. We already have the area of the other thing, the projector. If we compare these two things, remember the ratio, and that's what we have, the ratio of the image and the object is the scale factor squared. So if we put one over top of the other, we will get a value of 26.265625. So if we want to have the scale factor, we have to square root this. So the scale factor is the square root of 26.265625. Our answer is 5.125, no units. We then use this information to answer part B of this question. It says determine the dimensions of the whiteboard. So dimensions means how long is its length, how long is its width. So now we're using the scale factor. Okay, so remember we have the actual object multiplied by the scale factor will give us the image. So if we're looking at just what is 9, that is the width of our laptop, or the side. We multiply it by the scale factor, and that tells us that the width of the screen in front of the classroom is 46.125 inches. If we do that same calculation, 12 multiplied by the scale factor, we get 61.5. So when we talk about dimensions, the dimensions of our screen are 46.125 by 61.5 inches. Okay, example 3. If the area of two circles are 16 pi and 36 pi, what is the ratio of the radii? So that is the distance from the center of the circle to the outside. First of all, if you recall, area is equal to pi r squared. So what we want to find out is what is r equal to. So first of all, if we look at the first circle, it is equal to pi r squared, which is equal to 16 pi. But we want to find out what r is equal to. If we do some quick algebra, we can see that we can cancel out pi signs on both sides. There's one on each side, so they cancel each other out. That simplifies to r squared is equal to 16. If we square root both sides, we will see that r is equal to 4. So we have the radius for the first circle. We do the same thing for the second circle. Pi r squared is equal to 36 pi. We see that the pi's cancel out. We square root both sides, and we get r is equal to 6. But we're asked what is the ratio of these two things. 4 over 6, which simplifies to 2 over 3. And the writing is kind of small on this side because we want to show you two methods to do this. The second method, what we do here is we take the two areas, 16 pi over 36 pi. If we simplify this, moving from left to right, we see that there's a pi on the top and bottom. We cancel those out. We get left 16 over 36. After that, we divide the top and the bottom both by 4. 16 divided by 4 is 4. 36 divided by 4 is 9. And that simplifies to 4 over 9. But remember, this is the ratio of areas. So what we have to do then is square root that. So the ratio of 4 over 9 square rooted, or the square root of 4 over 9 is 2 over 3. So we got the same answer. So part B says, what is the ratio of the circumferences? If you forget, the ratio of the circumference formula is 2 pi r. So let's look at circle 1. Circle 1 is 2 pi r. We just found out that the radius is 4. So we can write this as 2 pi 4. Circle 2, again using the same formula, but we got a different radius, which we said was 6. So this is our two circumferences here for the two circles. What's the ratio of these two things? We put one over top of the other, 2 pi 4 over 2 pi 6. We see that things on the top cancel out things on the bottom. We can cross out the 2's. We can cross out the pi's. We get 4 over 6. We simplify this, we get 2 over 3. So the answer is exactly the same, but the work that you get to get to the final answer is different. And we are going to work on 8.4 practice next time we see you in class.